Hello everyone, I'm Hugh. Well, no, I did it again. One sec. Hello everyone, I'm Hugh from Loxon and welcome to today's video looking at the solution to our earlier config challenge. So just to remind you of what the config challenge was, we had a scenario with a commercial building where they wanted to monitor for leaks on their water system because last year they had a bad leak, cost them a lot of money, a lot of downtime, and they want to make sure it doesn't happen again. So what they want is in key areas such as bathrooms, etc., they want to have water sensors just to monitor for any leaks. Anywhere there'll be a flexible pipe. In a server room or a plant room, they want to have leak detection tape, which is a physical sticky tape that goes all the way around whatever device it is. And they then, obviously, if that goes off, they want it to start calling through a list of people. And if that list of people doesn't answer, then they want it to trigger a main alarm, and they also want it to shut off the main water incomer. So that's the first bit of the config challenge. The second bit is the extra bit for anyone that got this far, was actually monitoring how much water was going through the building. So what we said was that an average employee, based on an online source, uses around 50 litres of water per day. And this building has 30 employees. And so what we want to do is monitor the water usage day by day. And if it exceeds a set threshold, we want it to send an alert to a member of the facilities management staff. Excellent. So let's get started. And to help me along, I have a demo case as well that I can configure up, and I can show you the relays flashing, lights flashing, hopefully, and we'll use this as well. So what I'm going to do is I'm going to change my camera over to make sure that you are seeing the demo case instead of me. And then I'm going to show you my config screen here. So here is config. Now, the first thing we probably want to do is we probably want to sort out this water alarm. So if I just make sure that I have the scenario in front of me as well. So what we have in high-risk areas of the building, such as bathrooms, we need to have leak detectors. So the first thing we need is a leak detector. Now, obviously, we could use a Loxon water sensor air for this if we wanted to, or for demonstration purposes here, or because we may have a third-party product, I'm going to use a digital input. So I'm going to use digital input 3 from my demo case here. So that's the first bit. The second bit is our leak detection tape in both the plant room and in the server room. And as you can see, I've already created my digital inputs for them. And I've already given my digital inputs the category of security and the correct room, because the block that I'm about to use next will pull both the category and the room data through to showcase it for you. And what we essentially want is when one of these goes off, it means that there is a water alarm. And so the block that we're going to use for this is the fire and water alarm block. We are then going to, on this block, be using the IW input for these sensors. So all of these sensors into IW, and you can see the block goes green. Now, I also probably want to make sure that I rename this block, because it's not doing fire, it's only doing water. So there is my water alarm block sorted. Now what I want next is if any of these sensors go off, I want to activate an alarm chain that starts calling the following people in order until one of them answers: the facilities manager, the IT manager, and the managing director of the company. So to do that, I can use a brand new block that we have called the alarm sequence. The alarm sequence does just this: calls people in order until a defined acceptance of the alarm. And so what I need to do is I then need to link my fire and water alarm block into my alarm sequence block. And to do that, I can use the preliminary alarm output. So the way that the fire and water alarm block works is it goes into a preliminary alarm, then it goes into a main alarm. So I can take the preliminary alarm output and I can link that into the alarm input of the alarm sequence. So that will trigger my alarm sequence. On my alarm sequence, I then know that I need to be calling 3 people. So I'm going to put 3 outputs there. And then under messages, I need to make sure that I have 3 callers created. So Loxon caller. In here, I would define the phone number, you have to remember to put the country code at the beginning of it for it to work. So 0044 for the UK. And those would be my 3 callers. The other thing I've said is I want to have those people be able to acknowledge the alarm. So I want to make sure that if one of those answers, they can acknowledge it. So I need to remember to tick allow response on all of these as well. And so what I can then do is drag each one of these out, and I can then decide on the order I want them in. So I want the facilities manager first, then I want the IT manager, then I want the managing director. So what I've put then is one of them can answer and they can acknowledge this. And the best way to do that is they can press a physical button on their mobile phone. So let's say it is key 0 on their mobile phone. They can press and it will acknowledge the alarm. And so what I can do is I can take them into the fire and water alarm block, and there is an input C, which is acknowledge alarm. So if any of them press 0, it means that they acknowledge that alarm, because it could just be that somebody's messy washing their hands. The next bit, if no one answers on the first round of calling, then a solenoid valve shall shut. So on the main screen, we have a solenoid valve fitted. If none of these people answer on the first try of calling them, it should shut that valve. And so the first thing we need to make sure is in the parameters of the alarm sequence, what the reaction time is. So that is how long each person has to answer their phone and react to it before it moves on to the next person. So 30 seconds is probably about right. The next parameter is the maximum number of repetitions. So we said we want it to be within the first call round. So I'm going to put that to 1. So that would be my alarm sequence and my water alarm. That bit is done. The next bit is the solenoid valve. For the solenoid valve, I'm going to move back over to the water alarm, because in the water alarm, you can say what the alarm delay is before it goes to the main alarm. So from the preliminary alarm, which starts the alarm sequence, how far before the main alarm? Now, if we've said that each of these has 30 seconds to answer, that means that we've got a 90-second period of time before it should move back to the water alarm. So what we could do is we could probably say in here 100 seconds, just so that there's that 10-second interval for one of them to quickly log into their phone and acknowledge the alarm. So after 100 seconds, if none of them have pressed their 0 key to acknowledge the alarm, the main alarm will go off. And it's the main alarm that we want to link to that solenoid valve. And so what I'm going to do, because we're most likely going to use this main alarm output for other things other than just the solenoid valve, I'm going to do this as a memory flag. So I'm going to put a memory flag onto Q2, which is the main alarm. And I'm going to call that memory flag main alarm. And then what I need to do is, with this solenoid valve, I essentially need to recognize when this alarm is turning on and off. And then I need to switch the valve as a result of that. So I'm going to put a switch block in there. I'm going to take my mains water solenoid and put it onto the output of my switch block. Now I need to define the logic where that output goes on. So Q2 is just a single output. It's on or it's off. So it doesn't work to put it in trigger, because the first time the water alarm goes off, it'll turn the solenoid on, but the solenoid won't turn back off until the water alarm actually turns on again. So I need to turn this single output into an on and an off signal. The best way to do that is with edge detection. So with edge detection, I'll be detecting the rising and the falling edge of that main alarm output. So then the rising edge can turn this switch block on, and the falling edge can turn this switch block back off again. So that would be my logic for the main solenoid. Now this solenoid here may be normally open or it may be normally closed. So I've assumed that this solenoid is normally open, and that when you close the contact on it is when the solenoid valve closes. It could be the opposite way around. Okay, excellent. So that is, if no one answers on the first call, then a solenoid valve on the main water inlet will close to prevent further water entering the building, and the building should then trigger an alarm for a water leak. So there are many ways that we could trigger an overall building alarm for a water leak. The best way is probably if we assume that the main office has lights and that Loxon is controlling those lights. The simplest thing to do would probably just be to have Loxon flash those lights. So if I just program the lights on the LED strip in my demo case to be in the office, then we actually have an input on a lighting controller, FA. No, sorry, forgive me. FA is on the music block. A is the one on the lighting controller, which is the alarm input, which makes the lights flash at the brightness provided in parameter BA. So we can then take that main alarm input and we can put it on A. If we do by chance have music as well in the office, because it's a snazzy office, then we could, of course, also take the music and then we could use that FA input, which is the fire and water alarm input, and tie that main alarm into there as well. So that would be our lights flashing, and that would be our music going off. And if I save that in, that is the primary scenario for us sorted. So when that saves in, I'm just going to head over to this water alarm block. I'll start live view, and then I'll trigger one of these sensors off for you. So that should be finishing saving in just about now. There we go. I'll start live view. And as you can see, at the moment, everything is safe, everything is secure, everything is happy. One of these sensors goes off. You can see it's just started triggering this alarm sequence. So this alarm sequence will spend 30 seconds ringing between each number. While it's doing that, if I head over to the web interface for you to show you what it looks like on there, and you'll get an idea of this as well. So here is the web interface. Just log into this. And we can see that the water alarm has gone off. It's in preliminary alarm, and it's also telling us what has gone off. The plant room, the leak detection tape. So that's brilliant. You can see we can also acknowledge it from here as well. So back to config, we can see we're on the second person now. After a few more seconds, we'll get to the managing director, and then 30 more seconds, we will get to the solenoid valve turning off. So while all that is going through, I'll explain the next bit. So that is the main part of our scenario sorted. High risk areas, leak detectors. If the leak detector goes off, it rings through the alarm sequence in order. If nobody answers on the first call through, it will open a solenoid valve or close a solenoid valve to shut off the mains water. And at that point, it will also make all of the lights flash and all of the music go off as an alarm siren in the office to alert people. So the next extra challenge is actually monitoring the usage of water to say whether that is correct or not. So as you can see, we've just got onto the main part of the alarm. Oh, sorry, we are just about to get onto the main part of the alarm in a few more seconds. There we go, main alarm. Solenoid valve has closed, and if you can see my demo case over here, you can see that the lights on that are flashing as well. So that is excellent. And then whoever it is that's responsible could come in here and they could acknowledge the alarm, and it's all happy and safe again. So then, the extra challenge, which is the water meter. So first of all, let's create a new page for this water meter, just so that we keep everything nice and clean. And this is probably going to be in the central area of the building. So what we have is a water meter installed on the main water inlet that will give a pulse for every 10 litres of water used. On average, an employee will use 50 litres of water per day in the office, and the building has 30 employees who work Monday to Friday, 8 AM until 5 PM. So the first thing we need to do is count these pulses and turn them into something usable. And there is a function block that is perfectly suited to this, and that's the utility meter. So what we can do is we can take that water meter into the trigger of the utility meter, and then within the parameters of the utility meter, we can say the pulse for units. So if it pulses once for every 10 litres, the impulse that we need to put in here would be 0.1. So then 1 pulse would equal 10. So that would be how we get 10 litres from 1 pulse. The next bit we need is we need to know today's water, because as we've said, an employee uses 50 litres of water per day. So we need a day value. Now on the utility meter, we have exactly this on AQ1. AQ1 is consumption today, and that will always reset itself as well. So that will be the output that we want to use. Now the big question is around how we recognize the difference between a normal working day and outside of hours. Because even though it's not specified in this, we can assume that if we want to monitor 50 litres per person per day, 8 AM until 5 PM, we probably also want to know what happens outside of those hours as well when the building isn't occupied. So if we make a safe assumption that when nobody's there, the building will be using about a litre per hour maximum, we need to compare the AQ1 value, so the consumption today, against what day it actually is. Now, there are a few ways of doing this. For instance, one way that we could do it is we actually have, under times, an option for, where is it? Day. So current day of the month. We also have various other options in here that will give us a 0 to 6, depending on which day it is. We'll have, there we go, current day of the week, 0 to 6, where 0 equals Monday. So we could use those. So we could take weekday, and if we know 0 is Monday, that means 0 Monday, 1 is Tuesday, 3 is Wednesday, 4 is Thursday, 5 is Friday. So we have to know that between a 1 and a 5 equals however much 50 times 30 will be. And then if it's 6 or 7, etc., we then go for a lower number. So that's one way of doing it. That, however, wouldn't be my preferred way. The reason being is that will only tell us Monday to Friday and then Saturday and Sunday. But what if it's Christmas Day? Christmas Day could fall any day of the week, but the building wouldn't be occupied. That's a public holiday. And so what we want is we want something that can tell the difference between a public holiday, a weekday, and a weekend. And there is one block that can do this, and that's the schedule block. So what we can do is we can put a schedule block there. And the other great thing about a schedule block is we can make the output of a schedule block either analog or digital. So by default, it's digital. We can untick that and it now becomes analog. So we can say that on Monday through to Friday, it will give us a value of 1. But then on Saturday, Sunday, and public holidays, we can say it will give us a value of 2. So it'll output either a 1 or a 2, depending on the day of the week that it is, or whether it's a public holiday. So 1 for Monday to Friday, 2 for weekend or public holiday. The next thing is we probably don't need to see this in the app because this is just being used for internalized logic, so we can untick that. The second bit is what days of the year are actually public holidays. Well, what we can do is up here, we can go to operating times, and there is actually pre-built in here UK operating times. So there you go, Boxing Day, Christmas Day, Diamond Jubilee holiday, May Bank holiday, etc., etc., etc. And whenever these become true, it activates the assigned operating mode of public holiday, which as you can see in here, we've already given it a value of 2. So now we know whether it's a working day or a non-working day. We need to compare that against the amount of water that's been used. And so what we need to do is we need to have essentially a truth table that says if it is a value of 1, so a weekday, and water goes above X, activate, or if it is a value of 2, so not weekday, and a value of Y goes off, then activate X. And the best way to do that is through a status block. So a status block allows us to make some quite complex logic. And so what we can do with the status block is we can take our schedule and we can put that into AI1, and we can take our consumption today and we can put that into AI2. Again, we probably don't need to see the status block in the app, so we can untick that. And then if we double click on the status block, this is where we can make the magic happen. So what we can do, I just try and make that so you can see it all. AI1 is our schedule. So I can say if AI1 equals 1, aka it's a work day, and AI2, so the flow is greater than whatever 50 times 30 would be, so 50 litres by 30 employees, and then adding a litre per hour for all of the non-working hours extra on that day. I believe that would equal 1,515. So it would have to exceed 1,515 litres on a day that equals a 1 to trigger an alarm, and then the state value would be 1. But then the second rule would be if AI1 equals 2, so it's a non-work day, and AI2, so the flow, is greater than 24, because we've said that it is a litre per hour, then that would also trigger an alarm, or that would also output a value. And then the final bit there is that it should send a notification to our facilities manager that there is a potential slow leak. And so there are several ways that we could do this. Again, through messages. We could ring them again, or we could send them a push notification, or we could send them an email. So we could make this email for potential leak. Put them in an address. Give them a subject. So potential leak detected. Take this out and assign it to that output of the status block. Save that in. And then if I, again, once that is saved in, go into live view. Just one more second. Live view. There we go. So currently we've used 0 litres today. As you'll see, it's still telling me in kilowatts. That's because on many blocks, we need to define what the value actually is. So we would need to say what we're actually measuring in. So you can now see that's changed to litres. And then what I can do is if I start triggering that input, you can see that the water value is rising. So every pulse is 10 litres and it's going up. And because it's got a value of 1, because for me today, it's currently middle of the week, you can see that I have to get quite high, probably all the way up. I said 1,515 litres. So I start cranking this very quickly. Remarkably difficult to reach that figure. Probably should have gone for something lower. And there we go. Now we're over that value. We've got a potential leak, and that's sent a message to our facilities manager. However, if I now do simulation to show you it's a weekend instead, so if I now simulate for a Saturday and start that, you can now see that it's giving me a value of 2. So now all I need to do is go above 24 for it to again send that output to 1 and therefore the email. So you can see now it's a value of 2, that's gone above 24, and that's given me a value of 1. So it would have triggered this email alert. And there we have it, the complete scenario sorted. So just to finish off with, I will stop showing my screen for a second, just so that you can see the demo case and you can see that nice and big. And then what I'm going to do, trigger one of those sensors, and that will have just triggered my alarm sequence. And what I've just thought is actually waiting for all of that to happen again, 30 seconds each time, is probably a little bit too long. So I'm going to shorten that reaction time to 5 seconds per person, and then make it 20 seconds maximum on the main alarm, and then save that in, just so that I don't have to make you sit around and wait here for 3 minutes just to watch some lights flash. And there we go. Now that I've shortened that delay, you can see that the lights are going off. And then back to my screen and back to the app. Water alarm's going off. Acknowledge it. The lights stop flashing. So just to recap on all of that, what we have is a fire and water alarm block. That fire and water alarm block on the preliminary alarm triggers an alarm sequence. That alarm sequence starts ringing through each of the dedicated outputs. Each of them, by default, have 30 seconds to answer, and we can set the maximum number of repetitions as well that it will go through. If none of them answer within that time period, then the main alarm is going to activate on the water alarm, because I will have set the main alarm time to be slightly longer than the ring through cycle on the alarm sequence. That will activate the main alarm. On the main alarm, two things will happen. The first is that an edge detection block will send a rising edge pulse into a switch block to close the main water solenoid. The second is that a memory flag will go to lights and music in the office to make them all flash, to make all the music sound as a siren, and so everyone knows that the building is in alarm. If any of the alarm sequence people here answer the call and press the 0 key on their phone, they will stop the alarm. So they will stop both the water alarm and the alarm sequence. And it will also then turn Q2 to off, which will then reset this switch block so it will open the solenoid back up. And then for predictive monitoring, we take the water meter, we put it into a utility meter block, count the number of pulses and what they mean, and then we take the value for today's consumption of water, compare it against the value for whether it is a work day or a non-work day into a status block to decide whether that is too much water for that particular day. And that is our entire scenario fixed and solved. Brilliant. I think that about sums it up. I hope you've enjoyed. I hope that you can see the benefits of doing something like this, because in many, many cases, prevention will be better than cure, especially on this water metering side of things where we're monitoring for a potential leak, because that is something that an insurance company very regularly won't pay out for because it's a maintenance issue. So I hope that you've enjoyed. Please join me again next time. Thank you very much for watching.